Alrighty, so I think this now actually worked. Fingers crossed. I have to explain why I think Niverio put this J here. Although I think in the time I've had to stare at this grid, I think I've proven that I'm wrong. But yes, Alima says exactly the thing I was going to say, which is that this being stream 94.5 makes it sound to me like we're describing a radio station. Uh-oh. Ambrose is only at 144p. Hopefully I'm not, for some reason, only at 144p. I don't seem to be dropping frames or anything. Yes, if you were very, very cold, then you might have a temperature of that. Okay, so when we last left off, we had discovered that J was 0 because due to Fillomino rules, any other letter 0 would put two ominoes of the same size next to each other, which would break it. So J was 0, and my guess was that that was a reminder that this question mark exactly could be 0, that was why Niverio had done that. And so I think I can actually prove that's not the case. So I think Niverio was just being a cheeky something when he did it. Because that if this were a 10, it would make this cell an 11. And 11 isn't 1b different from 2. So I don't think this question mark is a 0. So I think it was not for an educational purpose, we'll say. But I'll tell you what I can do, which is to put a thing here. Because if the 11 doesn't touch the 2, then I would need something in here that is then 1b different from 11. It would need to be like a 23 or something. I mean, there could be a 23 here, and there's an 11 over here. I mean, it's possible. It just seems very unlikely. Okay, we're going to go ahead and mark this. So this omino is its own omino, and this omino is huge, as was being pointed out, because this omino is at least 10 different from 1. So this is 11 plus. And so I think if I put a medium, I think I can actually write 11 plus into the cell. So this will be 11 plus. Yeah, I think the most likely is a 13, but we'll see because of the 10 in this column. Let's see. So here I get a C difference. I'm trying to see exactly. I didn't actually, while the power was out, think about anything other than if I was right that this was going to be a 10, which is not really a productive way to sort of advance the solve of the puzzle, so to speak. Let's see. Ah, yes. Okay, so this digit. Oh, okay. So this is good. Okay, so Josh has a good point, which is that this digit is also 11 plus because it's at least 1a different, and this is actually at least 12 for this one. Yeah, the rules are a bit cut off. I don't think you can really reasonably display rules in Penpa puzzles, because if I shrink the rules, it makes the grid even smaller, and the grid is already quite difficult to read if you're on mobile. So I think it's just one of the things that makes Penpa not great. So like it should be noted, the fact that this sort of shows up at all with the rules is already something that Penpa does not natively do. It's a plugin that someone wrote, but I don't think there's a lot. Maybe I could just slide it over without losing too much. Can I just slide it over without losing too much? It'll make it look oops. And then I wanted to just make my head a little bigger so that I cover the thing. Okay, I think that actually fit without. Let's see. Now I'm going to be make sure the buttons don't show up at the bottom. It's a little better. But yeah, the usually on Penpa it doesn't work this way, because usually the rules on Penpa go on beyond the bottom. So I usually just assume people are going to put it on LMD. But for this one, they actually do fit here. Oh yeah, Tristan, can you dump a link to the thing here? So this is 12 plus because this is 1A different. And so the question is question mark A? Because if question mark is A, then these two are the same size, which is very plausible. If question mark isn't A, then these two are different, which would be very interesting. I do know that there are only a total of 5 different ominoes in this row. There are a total of 5 different ominoes in this column. Let's see. I mean, it's very tempting for this 3 here to be a difference between this omino and the 10, making this a 13, but I don't see a way to prove it yet. This cell I actually know is less than 10. So this cell is 9 minus. Let me fill that in. 9 minus. I know this row is... Oh, no, it's 10 minus. Sorry, it's 10 minus. Why do I know this cell is less than 10? It's because the difference between 1 and this cell is at most 9, because it's C. So this is 10 minus. I also hope we have a good evening with Daniel. We're going to a cave today, so we're going to have a fun adventure. It should be great. I enjoyed our little small town Iowa pride yesterday. It was delightful. Okay, so this C is interesting because it's the same as that C. So it's suggestive that there's going to be another 1 in this row, but it might not. Doesn't have to. Let's see. Isabella's looking at row 8, column 7. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Visit a cave today and a canal view tomorrow. That's a good idea. So this is E different from 1, and E and C are different. So that Isabella's correct. The 10 minus can never take this cell. And keep in mind the 11 plus and the 12 plus are probably the same, but we don't know they're the same. But they're definitely different from the 10 minus. But the 10 minus could be the same as this 10, because 10 is 10 or less. This FF is interesting, because it's saying that we go up by F and then up by F again. Yeah, the 11 plus definitely can't take this, because 11 plus isn't 10 or less. Oh, Kurabon had a point that I think I missed. Oh, if this... So, okay, so... you'd have a repeat of 1A. I counted row 8, column 7 is this cell, right? Yeah, row 8, column 7 is this cell. That's row 8, column 7, I think. Am I counting wrong? Oh, that's row 7, column 7. This is row 8, column 7. Is this 9 by 9? 2, 3, 1, 2, 3, 1, 2, 3. Ah, yes, okay. Yes. That's why. It's 9 by 9. Pencil puzzles are usually 10 by 10, are usually multiples of 5, but Niverio wanted to be different. So this is actually 9 by 9. Okay. So there are 81 total cells to play with. It's a good point to notice that if we sum all the Fillomino tiles, we're going to get to 81, which I assume we're going to have to use. Okay. So this cell can't be... So we're saying, so Isabella's saying this cell can't be the 11 plus. Right, because this is also 10 minus. For exactly the same reason as this was 10 minus. This cell is 10 minus. Oops, sorry, not plus, minus. Because this cell is 1 plus E, and 1 plus E is at most 10. So this is also a 10 minus. And so the point is that now tells me this 11 plus, as chat was saying, can't escape out the left. It has to escape out the right, which means that this thing is going to take at the very least. So this is now a 12 plus again, because now it is the same omino as this one. So this is 12. Oops. Ah, no. Curse you. It is 12 plus. But now this thing, whatever it is, it could take this cell, but I need to get to at least 10. So that means I'm going to go 1, 2, 3, 4, 5, 6, 7. I always need to take all of these, no matter what I do, because I can't be the same as any of those other things. So we need to go at least that far. All 6 of those cells are definitely in here. And now that's big for this 10, because now this 10 definitely has to come out here. But I actually know that this 10 and this 10 minus and this 10 minus are not the same 10 minus. Because one of these is E different from 1, and one of them is C different from 1. And so that's going to give me lots of edges forced into the grid. And now the purple has to come out to the left, because no matter what, I'm never finishing in this one cell. So that just can't happen. I do know that there's an edge here with the 10 for sure. And so I now know that yellow is 13, because I now have the edge. So yellow is 13. So I think that means I need to go to normal number and write 13 in all of these cells. There is a nice version of something for doing Fillomino puzzles that lets you just drag the number that Puzzlink will look at. I've never understood why Penpa doesn't do that, or if it does, I don't know how. To do the, like, just enter the number once and then you just drag it around the puzzle. Okay, so let's see. So A is 2 is a good point, because this difference is 12. Thank you, Nebu. So I can fill in A is 2. So are there other 2s that exist? Yes. So there is a 2 going down here. So this is connecting to a 4 or an 8. Let's see. Okay, so yeah, so we're up here, we're 8 different, and then we have any number of clues. Well, this A is the A we already used. This A in row 8. Okay, so people are trying to contemplate what's going on with this 1B. So there's a couple options. So either this cell is yellow, in which case the difference between yellow and blue is a 2-digit difference. But right, this cell can't be purple, is what Chad is pointing out, because if this cell was purple, then purple we know is 10 or less. And so 10 or less would have a single digit, not a double digit difference. And I also can't make this sorry, I scrolled. I can't make this the start of a new omino, because it would be size 1, and 1 and 2 do not have a double-digit difference. So in fact, this definitely is a yellow. We can bound that in. We can fill in the 2. Purple definitely is not 2. I think we know, right? Well, let's argue it carefully that purple is not 2. Oh, yeah, purple definitely isn't 2, because if purple took the cell, it wouldn't be 2 in size. Hey, Logan. So there is a proof for you that purple is not 2. Uh-oh. Niverio says we're already wrong. Okay. So this cell's actually purple. How is this cell actually purple? Right. The 2 could come over here. Right. Okay, so this is either... But the point is, this could also be the 2. But the point is... Oh, the difference would be with this. Got it. Okay, never mind. Sorry. The difference would then be with this if this came down not with that. You're right. Okay. So Jim is correct. If this 10 minus was 3, it could go here. Well, it couldn't be 3. It could be... It can't be 3, because then the difference would be 10, and the difference can't be 10, because B is not 0. So I think, actually, we know this cell's not purple. Because if this cell is purple, again, I would need a double-digit difference between this this thing. And the only way I could get a double-digit difference is if purple is 1, 2, or 3, but purple can't be 1, 2, or 3. 3 is the only one that's hard to argue, because if purple is 3, it would make B 0. So purple doesn't come down. And so, therefore, I don't know which way it goes. I was wrong about knowing which way it went. But I know that this is an intersection of a 2 and a 13. But I don't know if this is the 2 or the 13. But that intersection either happens here or here. So the 2 and the 13 here that meet are going to force that B is 1. So B is definitely 1, as chat said. But the thing is, I don't know whether this is a yellow or a 2. I do know that this cell that 2 isn't purple. Because then purple would already have size 3, and that's not going to work. Okay. So now... So B is 1. Is that interesting anywhere? It's going to be interesting in this column way later down the line. The fact that there's a difference of 1 there is kind of interesting. So Niverio is recommending that I gray off the clues I've used. This seems very likely to result in an error to me. But I'm going to try it. So this row we've completely used. The 1B we know we've used. The 3 we know we've used. Let's see. So the C here, we have not quite used. Let's see. Well, the ... doesn't mean anything, Isabella. The ... could be anything. So, ... is no information. Because the rules specifically state that ... could be no clues. So, all this clue... So, I think the ... unless I'm wrong, I don't think the ... could possibly tell us anything. It just says there's 0 or more regions here. Okay, so... Sorry, Kerbon was saying this can't be 1. I already knew this wasn't 1, didn't I? Yeah, I already knew this. I already proved a long time ago. There was nothing wrong with my argument that this couldn't be 1 a long time ago. So that's not a problem. So this difference is C and this difference is C. I don't think that's interesting, is it? No, that's not the difference that's C. This difference is C. This difference is C and this difference is C. So I need to go up or down C and then up or down C again to get from 1 to 13. So if I went up C and then down C, 1 and 13 would be equal. That's not going to work. So I have to go up C and then up C again to get to 13. And so that means C is 6 because I need to go up twice. It's because of these two borders. So green is 6. Right? Why is it 7? I thought it would be 6 because I need to go 6 up and then 6 up again. I think green is 6. Sorry, green is 7. C is 6. Sorry, it's saying the wrong thing. Okay, so C is 6. This is a 7 because I need to go 6 up. Okay, so now this C is interesting because this C connects these two. So purple is 6 different from whatever this number is. So that tells me this cell can't be yellow, funnily enough, because if this cell was yellow, that would make purple 6 different from 13. It would have to be 7, but purple can't be 7. So yellow can't go left. So yellow ends here, and so therefore the 2 goes right. That lets us sort of finish the 2. Give the 2 its own little color. That was very cute. And so now I know what purple is, because now purple is 6 different from 2, and so it must be 8. B is already 1. We've already marked that, right? So we have that purple is 8. Yes, we've marked that. Let's see. So, okay, so this column, if we're going to keep going with Niverio's comment, this column, we've used all the clues. Let's see. The question mark wasn't a 0. Let's see. So that was 6. And then at the top, we have an I. Let's see. So if purple went up here, this difference would be 1, and it can't be because C is 6, actually. So purple definitely doesn't go up. And so therefore purple goes left. What? The difference is E? No, the difference here is... Oh, it's D. Sorry. The argument's still perfectly correct, though. D can't be 1. 1 is already B, and B and D can't be the same. I just said the wrong letter, but yeah, so yeah, still right. So this is an 8. Let's see, okay. And so chat points out that this row tells me E is 7, because it's the difference between 1 and 8. So I, in fact, grade this, even though I had not completely used it. I think deciding what clues you've completely used is an art in this puzzle. Okay. So if purple doesn't go down, this cell is a 14. But it can't be a 14 because we know the difference is single digit. So purple can't go down. It can't be 14, Ambrose, because the rules specify, and I admit I think this is standard in pencil puzzles, so this is not shade at Niverio, but I really dislike using question mark for single digit as a convention. It is not how my brain works. But this can't be a 14, and so purple can't go down because I would need to go down by 6, and I can't. This that goes down. So I am a single digit different. Let's see. Okay. Sorry. Sorry. What I argued was actually the opposite. What I argued is purple has to go down, because if this is not purple, sorry, I just used the opposite. Purple has to go down is the actual thing I argued for, and then did the opposite. So we have that. So this question mark is actually a 6. This is an 8. Yes, I feel I do that a little less often in Sudoku, but I do it a lot in pencil puzzles, is to prove something and then do the exact opposite. But yeah, bracket 0 through 9, I would be a lot happier with for a way of indicating that something is a single digit number. Okay, so here we have, let me just mark up this one so I can try and keep track of where we are. So blue to yellow is that one. Blue to green is that one. Yeah, and I don't know anything else. The rest of this column until I get to the I is problematic. Tallcat got a 1 hour plus 1 Chang feature. Those don't happen very often. I have to say, Wen Chang doing frack is one of my coolest Sudoku moments as a setter. So people are saying green can't go up because if green goes up, right. If green goes up, this difference, which is F, would be 6, but F can't be 6 because C is 6. So agree, green can't go up. So green goes left. So, yeah, okay. In this column, we don't have anything else. There's a C, and there's eventually going to be a D over here. Let's see. Can purple go up? Purple can't go up now, because if this was purple, that would make a difference of 1, but that would be a D, and it can't be. So purple can't go up. Green can't go left, Garion points out, because if green goes left, then I'm going to be making C equal to 1, and C can't be 1, it's 6. And in fact, actually, what I could just do is, I know that this cell is 6 different from 8, because it's C different from 8. So I should actually just fill in what are the possibilities. It's either 2 or it's a 14. If it was a 14, though, that would make D 7, and E is already a 7. So this can't be a 14, it is a 2. And so that's the clean way to say that E goes up. Or sorry, that 7 goes up. So green goes up like that. It makes that a 7. I know that green doesn't go backwards for whatever reason. I had already argued that the 7 couldn't go up there, because if the 7 went up there, it would make the difference of 7 and 13 equal to F, and the difference of 7 and 13 can't be F. Okay, so that means this thing can't be yellow. I'll get to D as 5 in a second, but I want to handle the immediate consequences of everything I did. So that forces the yellow up here, which now forces... Now we can do a little bit with the 10. So the 10's going to have to come up like that. So this is also going to be 10. Now I want to think about the F thing. And I'll go ahead and I will fill in D as 5 now. Because that's that difference. Okay, but I need an F going in both directions here. So this number is F different from both 7 and 13. So it has to be midway between 7 and 13. What's the average of 7 and 13? It's 10. So this digit has to be 10. I realize I just said this digit has to be 10 and 10 isn't a digit. But this number has to be 10, which means that F is 3. Oops. Ah! No! Undo. Means that F is 3. And so this is also 10. So this 13 now is going to have to go up. I don't know if it's possible that these are going to be the same 10, but I'm going to be able to do a lot of chasing, because now this 13 has to go up again, which is going to force the 10 up again. How many cells is my 13 at? 1, 2, 3, 4, 5, 6, 7, 8. Oh no, poor Zach didn't dance for the first digit in the grid. He was all distracted and scared by the power outage. I'll be sure he gets to dance extra for the next puzzle. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's still lots of 13ing to be done. Okay, I'm going to write in this triple. 1, 2, 3, 4, 5, 6, 7, 8, and 9. These are 4, 8, and 9. So there needs to be a difference of H up here somewhere, and H is going to have to be 4, 8, or 9. I don't really like the look of putting an 18 or a 19 in there, but whatever, we'll make it work somehow. Let's see. This 2 is going in one of those two directions. Let's see. If 2 went this way, it would break because F is 3, right? The 2 can't go up because if the 2 goes up, I'm looking at... Oh, no, it would be G. G different. Could it be G different? No. It would be D different. Sorry, I looked again at the wrong place. But this boundary, if the 2 went up, would be G, and it can't be. So the 2 doesn't go up. The 2 goes left. And then the 2 is done. So let's go ahead and box in the 2. Okay, so there's a B difference now. I know this digit is B different from 2. So this digit is either a 1 or a 3. Because those are the only numbers that are B different from 2. So this digit's a 1 or a 3. It's definitely not a 7, therefore. But now, if I look at it, this boundary, that is F, F, G. This boundary has to be G. And so this can't be a 1. Because if this were a 1, G would be 6, but C is 6. So this is a 3. Oops. Ah! This is a 3. Sorry. This is a 3. I'll get it right eventually. And so this being a 3 makes G 4. So now H and I are actually 8 and 9. So there's a gigantic omino in this column. Oh, not necessarily. It could be a very tiny one, because I could be 8 or 9 different from 10, but I could go down from 10. Never mind. I am incorrect. Okay, so there's a 3 here. And so that handles this column's clues. So I don't need to look at that column anymore. This column's clues are, this row's clues are done. This row's clues are done. Green can keep growing to there. It's a 7. Oops. It's a 7, which is then going to make the 10 grow more. Which is then going to make the 13 grow more, which is then going to make this 10 grow more. So let's write in those edges. So we can do the yellow and the pink. So let's see. So yeah, this row we only know stuff about the left side, so I don't know if we're in the left side yet. It's interesting. This row is very interesting because I need to know that there's a third border in the row. Okay, there's an I at the top. What is I? I is 8 or 9. So if yellow goes up, this is a 3 or a 4. That's... Oh, that doesn't work. Yeah, if yellow goes up, this is a 3 or a 4, and the 10 is broken. Because then yellow can't get out. So actually, sorry, then pink can't get out. So yeah, so if I look at this 10, if yellow goes up here, this thing becomes a 3 or a 4, and that doesn't work. So yellow doesn't go up. Yellow goes left. So this is a 13. So this 10 comes over. So now the 7 goes over, and now the 7 is not finished, actually. The 3 now has to go over. Let me do all the drawing in that comes from that. Let's see. So the 10 there. These 10s are now definitely different, right? Yeah, these 10s are now definitely different, so I should give them different colors. So this 10 can be, let's let this 10 be blue. Da-dee-dee-da-dee-da. This is a green. This little 3 over here can be orange. So we still have more things to look at. So I need another boundary in this column. There are at least 2 boundaries in this column, and if I let the 10 go up, there would only be 1, so that's not going to work. So the 10 actually cannot go up. So the 10 goes left instead, which is going to do this. So now I need to look at column 9, and when I look at column 9, I can ask, can this border be the I? And the answer is no, this border cannot be the I. So I actually need the I border here, and so I get to do that. So I get to push 1 further to the left. So we do that. Now the 13 still needs to grow, because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh yeah, the 13 still definitely needs to grow, which is going to make the 10 grow, which is going to make the green grow. And so now if I fill in the numbers, that's a 7, that's a 10, that's a 13, and that's a 10. And that finishes the 7. Oh, I didn't write 10 correctly. Let's try again. 10. So now the green is done. Oh, actually, the orange is now done as well. So the orange now needs to go 1 more to the left. So this is going to be a 3. And the orange is done. Okay. So now I need to look at what's going on in the top row. So let's fill these things in. So this thing needs to be h different from 10, and this thing needs to be I different from 10, which means that h and I are different which means these two are in different ominoes, because otherwise they would be the same difference from 10, which means there's an edge here, but that then automatically means this is a 1. I like that. That's very clever. So this is a 1. Sorry, I tried to fill in a 1. It didn't work. So therefore now so that tells me that h immediately is 9, and so then I is 8. This digit now has to be a 2, because it has to be 8 different from 10. Okay, I guess it's 2 or 18. I'm going to guess it's going to be 2, but it doesn't necessarily have to be. It could be 18. But this is a monomino in the corner. I will let you extemporaneize the monomino in the corner song. So this is a 2 or an 18. People are looking at this clue. Right. This is a single digit difference between the 1 and whatever this is. And so the single digit difference can't be 17. So this can't be an 18. So this is a 2. And that's a 2, which finishes the 2. So now I've got some shading to do. So these can be orange. This can be pink. This is a 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This will be 12. That needs to go out still. Good luck voting, Isabella. 10, 13. Got that. This is a cool puzzle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And actually not... I don't think there have been any difficult steps yet. So let's see. Okay, so we've got to keep going. So let's see. I say on the verge of there being a difficult step, but let's see. Okay, so like literally the hardest part of this puzzle, and it's a very difficult part, is reading and understanding the rules. Because the rules are, I won't say overwrought, but the rules are quite wrought. Let's see. So I need something that's A different from 6 somewhere. Let's see. Okay, I just run out of space. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay. Yes. If that's a great spot from chat. If yellow goes up, then this 10 omino peaks out at 9. So this cannot go up. So now I think this is it finishing. If I remember how the count works. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. I believe this is now 13. So this is a 13. This is a 10. And now that 6 is going to be very relevant because I need a difference of 6. Sorry, I need a difference of A, and the difference of A is 2. So this can't go down. If the 6 went down, I would be saying the difference between 6 and 13 is 2, which it's not. So this is a 4 or an 8. For sure. I can center mark that if I go into Sudoku mode. And so now I need to count how many cells there are that the 10 could even possibly get. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, and so the 10 needs to take all of these cells because it's the only cells it can possibly take. So these are all 10. So 10, 10, 10. Yes, not to be confused with 48. Okay, so whatever this is, it needs to come out, and then whatever the 6 is needs to come out a lot. So let's go ahead and make this green, I think. Maybe I'll regret that. So I'll go ahead and make this up here purple. So purple has to come out like that. Now I don't have enough boundaries in this row yet, so I need an edge here. Because note, there's 4 boundaries in this row, and I've only put 3, so there's a boundary there. So that means purple has to go down. So purple goes there, which then forces green to go down, so green goes there. But green's not done yet, so green needs to come out like that. Purple is still not done, so purple actually needs to go there and there for the finish, so we get another monomino in the corner. So this I can box in, I can give it a color. Let's make it brown, I suppose. So that's a 1, sorry, that's a 1, not a 1 in the center, and these are all 6s. Okay, I know there are 4 total borders in this column. Let's see how many we have now. So currently we have 1 border there, 2 borders there. We've got a 3rd border here, so we need a 4th border, so that's not interesting. Let's see. Yeah, you got one of the longest, I am told. That is pretty cool. So, did I miscount my borders? 1, 2, 3, 4. I did miscount my borders. Right. I just didn't count this border for whatever reason. 1, 2, 3, 4. So I have all the borders in this column, so there are no borders. So this is a 10. And all 3 of these cells now have to be in the same region, and that region can only be the purple 8 region, because if that region is not the purple 8 region, then the purple 8 region can't finish. So these are all part of the purple 8. And then that is going to finish the purple 8, because I only get 1 more cell, and I need it to finish the purple 8. So, oops. So we're going to do that over to there. I don't know which of these is a 1 yet, but I will someday soon know, I hope. So there's an 8, an 8, and an 8. Probably one of these clues over here is going to tell me once I get there. This is a 10 I can fill in. Let's see. And so F is 3. So most likely this is my 3. I know I need a border in these cells somewhere, but I don't know which yet. It's the row 9 clue. Row 9 only has 4 borders, and we've already got 1, 2, 3. If I put the 1 here, that would make it 5 borders. That's a very good observation from Kurabon. Very smart. Okay, so that's the 1. That's the 8. So we go across here. It's a brown like that. Very nice spot. So now, welcome, Doomdiat, by the way. You missed out on the excitement of the power outage earlier. 1, 2, 3. So there needs to be another border in this row, and it has to go here. Because it's the only place for a border. And now the difference of these 2 cells is 3. Whatever that means. Let's see, G is 4. Okay, let me think about this. So, is it possible that there's a difference of 3 here and a difference of 4 here? I don't see a pleasant way to articulate why that can't be the case. There might be an unpleasant way, but I probably just am not looking at the right clue. Oh, I only get 1 more border in this entire column, so that's interesting. This still looks like I'm being set up for a gigantic look ahead, which I don't want to do. 2, 3, 4. Let's see. So how is my blue 10 doing? 4, 5, 6, 7, 8. Let's see. Garion says this has to be a blue 10, or we don't get enough borders in row 4. So is the argument if this is a 10, we don't... Is the argument really that this cell can't be a 10? Oh, no. Okay, I see the argument. Okay, got it. So here's Garion's argument, which is very clever and which I did not see, which is if this, imagine the world where this is not a 10. If this is not a 10, my 10 has to finish like that. But now my row 4 only has 2 borders. That's very clever. So this has to be a 10 in all universes. That was exactly the right question to ask. So very good spot. So now the claim is that that is enough to tell me that green can't be 8. So if green was 8, it would look like that, I think. And then the difference between 8 and 10 would be G, which is 4. But 8 and 10 do not differ by 4. So this is a 4. So 4, 4, 4, 4. And we can finish this here. So this digit, this cell, we know either contains a 6 or a 14. Those are my 2 options. If it was a 14, that seems likely to cause a problem, but I don't know that I can prove that it would. Is there, let me count. Maybe there aren't 14 cells left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, there are not 14 cells left, so it cannot be 14. So therefore, this cell must be 6. I knew when I started this puzzle that Niverio was going to make me count. So there we go. So that's a 6. So we'll go ahead and give the 6 a color. Let's let it be red. Now, no matter what the 6 does... Oh, actually, sorry. The 6 can't go up because it's a 6. Because it would touch another 6, which is awesome. So the 6 has to go down. So now... Now, if I count my borders in this column, I'm supposed to have 3 borders, and I have 3 borders. So red has to go down the entire rest of the column. But we should be very careful not to contemplate what that means for the betting tree, because otherwise we might have spoilers. So we have this row is some stuff. Okay, the 10 can't get there, though, right? 2, 3, 4, 5, 6, 7, 8, 9. Right. Blue only gets 1 more cell. It goes there or there. Okay, that's not actually helpful at all. It's this. It's that F. So this cell here has to be a 3 or a 9 for reasons that are not yet visible, but that you might infer after you've watched the rest of the solve and gone back and looked at it. This cell has to be a 3 or a 9 because of the F. It can't be a 9 because if it was a 9, I would have an awfully hard problem or an awfully hard time sort of filling in these things. So therefore, this is a 3. And so this is green, and we can actually finish our Grenomino. So our Grenomino does that. So now our red omino does that. And so now our blue has only one way to finish, which is that way. So that's a 10. So I will fill in these borders, fill in this border. So now I will fill in this 1. And now I have but to fill in the 6s in here. So let's see. That's a 6, that's a 6, that's a 6, that's a 6. And this, by Sudoku, is a 6. Hooray! Answer check even worked. Success. By the way, for the setting challenge, bonus points to all of you who make your pencil puzzles work in CTC so that I don't have to use Penpa. I feel like this would be very easy to make work in CTC rather than Penpa. But yeah, this is a very cool puzzle. I feel like this is sort of really the... yeah, there was. I basically had enough time to announce the setting challenge, and then our power went out. So we've got those. Yeah. That's right. Entering 2-digit numbers is a problem in CTC. So Tristan would like me to reiterate the challenge. So the challenge is as follows. So the challenge is. And Tristan will snip the version and post it to the channel, I'm sure, from the earlier version where I want the longer version. But set a pencil puzzle in a genre that you have never set a pencil puzzle before. And the goal is to strive for a difficulty that is in sort of the intersection of interesting and approachable. Ambrose specified that you should not strive for one that is neither interesting nor approachable. You should strive for one that is both interesting and approachable. And it has to not be a Sudoku. I actually think this is a 2 out of 5, if I'm being honest. I think this actually, I think I would have rated this a 2 out of 5 for difficulty. So this is the rare puzzle. I think I've literally never said that before about a pencil puzzle on LMD, but I actually think this one is overrated because LMD doesn't like doing this. Any puzzle I've ever posted that involved cryptogram stuff, which I really enjoy the cryptogram stuff, but any puzzle I've ever posted on LMD with cryptogram stuff that has taken forever for anyone to want to do. Yes, so if you've never set a pencil puzzle before, you can pick literally any pencil puzzle. Don't do number 2, it's too big. I would do number 2 unless you but if you tell me it's too big, I will not do number 2. Because I think that you rapidly approach what can reasonably be followed on a screen. Alrighty. The challenge is, I have, Glum Hippo, I have setting challenges where I do all the puzzles that people make for the challenge. So this is going to be after the Tallcat 100th anniversary celebration. We are going to do the challenge puzzles for these things. And I am going to try my darndest to convince people that pencil puzzles are cool, which is somehow, for some reason, is very difficult, but I'm going to try anyway. So that is part of the goal, is to do that. Yes. For Tallcat's 100th anniversary next Sunday. I don't think I have anything wrong with Puzzlink. Puzzlink links should be okay, I believe. I might have to figure out how to set up a scene for it. I very specifically said not Sudoku, just to clarify that. I said my bar is that if you get to the point in LMD where it asks, is your puzzle in essence a Sudoku, the answer must be no. That is my bar for what is valid and what is not for this particular extravaganza. Will balance out the fact that I set what was what was essentially only a Sudoku setting challenge as the first one. Alrighty. So I am going to pause I'm going to take a short break. And then when I return, we're going to do more puzzles. I believe when I return, in fact, we're going to do Tallcat's new puzzle before Simon gets to it. So we'll be back with a puzzle that has a name with an ampersand in it. So I will see you all very shortly. And if you like ampersands, you're going to be very happy. Alrighty, welcome back. I hope you enjoy the ampersand that is happily sitting between Ginnels and Snickets, which I'm sure are words. Can you snag this SSG puzzle for the bucket, Tristan, while you're watching? It sounds fascinating. And the last SSG puzzle I did was the one for the app, which was just spectacular. It was one of the most memorable from the CTC 500th anniversary pack. Alrighty. So what are the rules of this puzzle? So we have two standard variants here. Variant 1 is between lines. So the circles always have to bound the digits on the line. So in this case, if I put a 3 here and a 6 here, it would be saying that every digit on this line is from 4 and 5. So hint, this is not correct. because there aren't enough digits. But that's all that has to be true for between lines. There's no specified order, so this could be the big one or the small one. We don't know. Okay. And then the most complicated rule in all of Sudoku, which is skyscrapers. And so what is a skyscraper clue? A skyscraper clue, and so I'm just going to fill in this column in a... in this way. I'm just going to fill it in a random thing. So this clue is counting the number of skyscrapers you see starting from viewing here. So you have to imagine that you're standing on the X and you're looking in this direction. And so you see this building because literally it's right in front of your face. So that one you definitely see. But here's the joke, is you can't see the 1. Because the 1 is shorter than the 2, and so the 2 blocks the 1. But then just peeking its head over just a smidge over the 2 is the 3. So you do see the 3. And then just behind that, you see the 6. Because the 6 pokes its head way over the 3. But then the 6 blocks the view of the 5 and the 4 because it's taller than them. And then you do see the 9. And then the 9 blocks everything because the 9's the tallest building in the country. And so then the number here is the number of buildings you see. So you see 2, 3, 6, and 9. So you see these 4. So in fact, this case, the random string of digits I filled in actually correctly met the requirement. But that's how skyscraper clues work. And very often, and I already think this is going to be the case in this puzzle, skyscraper puzzles very often come down to thinking about the number 9. Because the 9 is always going to block the view of everything else. And so my first deduction in this puzzle is going to be about 9 in column 2. By the way, Tallcat, do you have a recommended betting tree for this puzzle? While I talk about the 9 in column 2. So I can't put the 9 in this column before this cell because I need to see 3 buildings. And so if I put the 9 here, I would see at most 2. If I put the 9 here, I would see only 1. But I can't put the 9 here because if I put the 9 here, I'm putting it on a between line. And that means I need to put a number bigger than 9 in one of these 2 circles. And that's not actually going to work. And so that's actually one of the standard deductions about between lines is you can never put 1s and 9s on them. In fact, actually, you can just fill in for between lines. The circles will always end up being 1 and 9. You can basically just fill that in almost any between lines puzzle. Although I see kindly Tallcat has not done that to me because I can't put 1 and 9 in all the between line circles here. But the thing I noticed when I first looked at the grid is that actually pushes the 9 all the way down into this box because I can't put the 9 on that between line either. So the 9 is over there. Row 4, column 8. Oh, by the way, I can put on the labels. Show. Wow, I found that quickly. Oh, I can't put on the labels, can I? Because the labels will interfere with the skyscraper clue, so I'm going to turn them off. Okay, row 4, column 8. This is the betting tree. Is that a betting X on the top of column 5? Yes. So the next thing I saw is what Chad is talking about, which is where does 9 go in box 2? And 9 in box 2, well, it can't be in this column at all. And again, it needs to be at least 3 down. In both of these. So the 9 in this column, the 9 in this box is always in one of these 2 cells. So actually none of these circles have 9s in them. So that is also interesting. Now we have these Tallcat between line shapes. And the thing about these is, if you've not seen this shape before, that Tallcat stole from me and I stole from someone else. I don't actually remember who I stole this shape from. Is that these 2 digits, because they're the circles on the between lines, they can't go there, they can't go there, and so both of these digits end up over here for sure. I feel like the Tallcat cat in the hat emoji should just have one of these as the smile. Just slightly alter the picture so that that's the smile on the cat in the hat, and it'll work out well. So I don't think that's useful yet, but at some point it's going to become useful, and by then I'm going to have forgotten about it, because that's how these puzzles always go for me. Oops, sorry, I should not delete the 9s. So the 9 actually in column 8, we can do the same trick. So it can't be before this cell, but then that's on a between line. So the 9 here is pushed all the way down to there. So we've got the 9s in those columns. Let's see. Does feel like we're supposed to think about 9s more. So the 9 in this box is bunched into one of these cells, which does not seem useful. The 9 in this box is boxed into one of these cells, which doesn't seem very useful. Although I probably actually want to just start highlighting cells that can be 9, because often in a skyscraper puzzle, this is something which is useful to do. I think any of these can be 9, as it currently sits. So we have these. People in chat are encouraging me to think about 8s, which is also interesting. So 8 could be here, but 8 can't be here, and 8 can't be here. So in column 8, actually, 8s are quite restricted, because I can't put an 8 here because neither of these circles can have a 9. And I can't put an 8 anywhere along here because neither of these circles can have a 9. So the 8's actually pushed down all the way into here, and the 8's not at the bottom because the 8... Oh, no, I don't know that. Sorry, I was going to say the 8 has to be before the 9, but the 8 doesn't have to be before the 9. But I know there's an 8 here. I know that can't be an 8, but I think this can be an 8, annoyingly, in this cell. So this doesn't break the skyscraper clue or anything like that. What about 8s in this box? That's a good question. So 8s in this box certainly don't go on the between line. They can't go in the top row. So the 8s are certainly in the bottom row, but I think the 8 could sneak into that cell. So 8 in this box is in one of this collection of cells, which is noteworthy. If the 8 was exactly here, would that do anything? I don't think so. Not immediately, anyway. I'm noticing for the first time we have 2 skyscraper clues here at the bottom, and then I'm quickly checking to see if they were cut off the screen for everyone else, but they were not. I just was not looking at them. And so these are pushing the 9 in this box either into this column or one of those 2 cells, which is interesting. Okay. So where else do we look? So we've pushed a lot of things off of these lines, because now the things on these lines can't even be as large as 7, because I don't have an 8 or a 9 to bound the 7. So these things on all of these lines are at most 6, and at least 1. So these are from 2, 3, 4, 5, 6, which is a little ridiculous to pencil mark, but I want to remind myself of it just in case it's useful. Let's see. And this could be a 6 if that's the 7, because I do have this given 7 I want to remember is there. Also, there's a 4 skyscraper over here I'm seeing for the first time. So none of those are 9. So actually 9 in this row is actually only in a handful of spots. Those are the only spots in this row that could be 9s. Is there a way I can rule out 9 from this cell? Because if I could rule out 9 from this cell, I could actually force 9 into this box. Why can't this cell be a 9? It sure looks like it can be a 9 to me. Welcome back, Mavir. I think I remembered right. Mavir, right? I think that's right. At least that was my approximately close enough attempt at pronouncing it. Is it because of this given 7? No, I don't think so. I was thinking if I wanted to do something like, if I wanted to put a 9 here, I would have to do 6, 7, 8, 9. But obviously I'm not placing a 9 there. But this 7 rules that out. So this 7 does make it a little difficult to put a 9 here, but I need to know something about this cell that I don't think I know. I mean, how do I know? Do I know this cell isn't a 9? Do I know anything about this circle at all? Oh, Andrew's right. I'm making the error that everyone makes, including me, every time I do a skyscraper clue, which is that 1, 2, 3, 9 will satisfy it. Oh, in box 6. In box 6. Right, okay, so sorry. Carl is correct. In box 6, I also can't have 8 or 9 in either of these circles, so these are also from 2, 3, 4, 5, 6. And that one's not a 4, I'm being informed kindly. Oh, actually, I can't have 6s either, because these circles also can't be 7. These circles can't be 7, 8, or 9. So these are from 2, 3, 4, 5. Let's see. Okay, so that's interesting. So I need one of these circles to be a 5 or a 6. And I need the other to be a 1 or a 2. So these two circles can only be from 1, 2, 5, 6. Because I need to have 3 numbers to put here. If I do not have 3 numbers to put here, then I run out of some problems. And so the only way I do that is if I make the low digit higher than 2, then I break. And if I make the high digit lower than 5, then I immediately break. So these are from 1, 2, 5, 6 is the only options. I think this digit can be 6, can't it? Because that could be the 7. Is there a reason why this can't be 6 and that's 7? To Jim Baker. Let's see. Okay, and so again, we know the 1, 2, and the 5, 6 are over here, whatever they are. So one of these is a 1, 2, one of them is a 5, 6. So there's definitely an 8 or 9 in one of these two cells, and it's definitely not there. So this is a ridiculous deduction that I don't know if is necessary, but I need to put both 1, 2, and 5, 6, whichever. I need to put these two circles over here. So I only have room for one more digit. That is, I only have room for 1, 8, or 9 over here. But I need to put 2 8 9s in the box, and I can't put any of them in any of those places. So this digit's always an 8 or a 9. So we have that. So these are from, actually, if you want to be specific, and this is a little ridiculous, but this is actually the 1, 2, the 5, 6, and the 8, 9 is exactly what is here in this collection of cells. So one of these two cells is an 8, 9 by Sudoku, but that's not very interesting. Let's see. Yes, I also love my gigantic tea mugs. By the way, the tea provided for this stream was provided partially by Daniel Silverstone, who brought me authentic British tea, which is very exciting. Okay. I do need 2 9s in the bottom 2 rows. Yeah, this 4. Okay. I know this cell can't be a 9 now. Right? No, I don't. I'm making the same stupid mistake that I make every time. I'm trying to say, if this is a 9, this would have to be 6, 7, 8, 9. But that's not how it works. It's not how it works. It's not how it works. Okay. I am a heathen who enjoys both coffee and tea. I think did I try the Yorkshire Gold? I think I liked it, but I've now forgotten what it is. There was this one South American tea that I really, really liked, and we stopped being able to get. I think that was my favorite. I forget the name of it, though. Okay. So, should I be asking if this can be 1/6? Is there a reason this can't be 1/6? I don't think so. Yes, mate is the type of tea. I was trying to think of the word in front of mate, but I cannot remember the word in front of mate. But maybe it's just mate. Let's see. Yerba, there we go. So, any linguists in chat who can tell me if the fact that matcha and mate both start with MAT is a coincidence or a linguistic or a something that's a function of something that's a function of language stuff. Okay, let's see. Tallcat is encouraging me to look at this geometry a little bit more. So I think Tallcat wants me to note that this digit definitely goes in here, so that these digits are actually 1, 2, 5, 6, 8, 9 are their candidates. And so there's a 1, 1, 2, 5, 6, 1, 8, and 1, 9 included in these cells. And so in particular, there's not a 7. That's gorgeous. I love that. I am beyond impressed with that setting. Because now, yes, where is 7 in column 4? And so I can't put the 7 down here because that has to go down there with the 8 and the 9. And so where's the 7 going? It's going in one of these two, but it can't go there because if it's there, I can only ever see 3 buildings. So in fact, we get our first digit out of nowhere, and it's this 7. And so we get to do a little 7 dance. Woo! Woo! Thank you. Okay, so that does tell me that the 8 has to come before the 9 in this column, because I need to see the 7 and the 8 and the 9. So that tells me that this digit's not the 9, and this digit's not the 8, which is just making the pencil marking more ridiculous. And this digit has to be less than 7, just for the record. Now this digit can't be a 6 anymore, is the point. Because now I can't put a number that's higher than 6 in this circle. So that 7 actually bought me that this can't be 6, which bought me the quadruple that had been hoped for by chat for some time. So now I have a 2, 3, 4, 5 quadruple, and so these cannot be 2 or 5. They are from 1, 6, 8, 9. But remember, this digit goes down here, so this digit can't be 2 or 5 anymore because of that quadruple in a weird way. So this 1 or 6 goes with the 8 or 9 down here. So this is a 1 or a 6. Now, this digit goes here by the same trick. This 1, 2, 5, 6. Where does it go? In this box, it goes here. So in this box, it has to go... Oh, no, it could go there. Darn it. It could go there. That's annoying. Because there's no reason this can't be that digit, is there? I don't think there is. If there is, I don't see it immediately. Let's see. Have I learned somehow that this can't be 8? I don't think I've learned somehow that this can't be 8. So I should just write in what this digit is what people are telling me, because it can't be... So I can just write in what this digit can be. I don't know if it's this circle or not, but I can write in what it can be. So it can only be 1, 6. It can only be 1, 6, because it can't be 7, 8, or 9, and it can't be 2, 3, 4, 5. So this is a 1, 6, regardless of whether it happens to be equal to this circle or not. Whether it's equal to that circle or not is a red herring that I invented to confuse all of you, apparently, including myself. So interesting. So I guess I can write in candidates for this cell. I'm admittedly not enthusiastic. 2, 3, 4, 5, I believe, are the candidates for this cell. And I think it could really be all of those. I don't see any reason it cannot be one of those. Doesn't immediately seem to be that. So people are talking about 7 in box 2. I don't think I know anything about 7 in box 2, do I? Oh, I do. Do I? 7 could be in the first row of box 2, can't it? It can't be there, but 7 in box 2 could go up there, or it could go down here, can't it? I don't think I see a reason why 7 can't go in the first row. Kurabon might see something I do not see. So I guess the point is this digit is in this, this digit is in this triple, because it's not there. So this digit in the quad needs to show up here. So I'm more interested... Pencil marking this did not excite me, but I'm more interested to realize I know where it goes in this box. And so I know it goes over in one of these two cells. I don't see why it's claimed it can't be 4 or 5 by the chat, by Screaming Ice Cube in particular. But there's probably some consequence of this I'm not quite seeing. Oh, it's because of the box 2 line. Oh, got it. Okay. It's because of box 2. Yeah, okay. Got it. Okay, so here's the thing I was not appreciating. I need to make sure that there are 3 digits to put here. So if this is 5, for example, then these could be from 2, 3, 4, say, if this is a 1. So if this is a 5, I can just scoot 2, 3, 4 and a 1 here. If this is a 4, now I have to either go up from 4 or down from 4, and neither direction gives me anywhere near enough candidates. So this can't be a 4 for sure. So Screaming Ice Cube totally right about the 4. I bet he's right, or I bet they're right about the 5 too, but I don't quite see how to look at it. But that's very nice. Okay, so if this is a 5... Yes. Okay, that's very Tallcatty. So this must be the intended Tallcatting. So if this is a 5, it makes both of these digits a 1, is the point. Because if this is a 5, that needs to be a 1 in order to fit 3 digits, but this needs to be a 1 in order to fit 1 digit. And so this can't be a 5 for that reason. Okay, so this is a 2 or a 3. And if that's a 2 or a 3, it makes this a 6. And makes that a 1. It means this can't be a 2. So now this has got to be at least 2, 3, 4, 5. This has got to be at least 6. Or I'm not getting there, because the lowest numbers I could put here now are 3, 4, 5. So this has got to be at least 6, but it can't be 6 and it can't be 8 or 9. So therefore this is a 7 by force. So now we do get that there is a 7 up here. You can't put 1, 2, 3. Oh, did I screw something up? How far do I have to go back? To the 5? Oh, I see. Okay, sorry. I see. So this being low doesn't mean this isn't also low, because there's only 1 digit here. So sorry, yeah, chat points out this could still be 3, 2, 1 is still an option if this is a 3. So I did not do that correctly. So yeah, we don't know quite what's happening yet, although we suspect. This digit still has to be high, though. That part was still correct. This has to be a 7, because I do have to go up from 2, 3 if I'm going to put 3 digits. And so this digit has to be at least a 6. Oh, but it could still be a 6 now, because this is a 6 or a 7 is the point. But it can't. But it could be a 6 now because of that. Hey, Andrew, welcome. Let's see. Yes, this is not 2 on the line. I had marked that before, but then I got confused. And made a leap I wasn't supposed to. Tallcat is encouraging me to think about where this digit goes in this box. Probably I need to think about these 3s or something. Oh, there's no 2 in here either, because these are not going to work. Smart point. So if this is a 7, it puts a 7 in one of these cells. It can't be that one, but I don't think I see why I can't just do a 7, 8, 9. It might break one of these 3s at the bottom, but I don't know. Oh, right. This can be a 2. Darn it. Yes, this can be a 2. These can't be 2, though. But right, because this could still go 3, 2, 1. Still possible. Let's see. Is there any way this digit is high? I don't think so. I think this digit has to be lower than this digit. So this digit here, if I wanted to go up, this could be 6. These could be 7, 8. And then that could be 9. I guess maybe that's vaguely possible. Uh, oh, wow. Okay, yes, that's very cute. Okay, got it. So this is a surprisingly geometric step for Tallcat. Uh, so here's the point. This 6-7 goes here in this box. I mean, I should say it's not the kind of geometry I associate with Tallcat. This 6-7 goes here in this box, and the point is those spots together see a 1-6 pair. And so because they see a 1-6 pair, this can't be a 6, it's a 7. So there is a 7 up here. It's very cool. I like that too. So, oh yeah, I've already said many times this can't be 7, but I went ahead and pencil marked it as 7 anyway, just recreationally. So this is a 7. Okay, where's the 7 going in this box? Maybe I don't know. Okay, so now these can't be high. Now this needs to be lower. Because I can't go 8, 9 here. So now this digit has to be at least 3 lower than 7. Because I could go 7, 6, 5. This is at most a 4, but it can't be a 4. So this digit can only be a 1, 2, or a 3. For whatever that is worth. So, interestingly, if 7 lands on this line, I have to put exactly an 8 exactly there. Otherwise, 7's going in this column. And then landing over down here. Interestingly enough. I mean, I know this isn't a 9 if I read my clues over here. Row 3, column 1 is somewhat limited, so it's at most 5. Can't be a 4, and so it could be 1, 2, 3. And let's see, do any of these do something crazy in the row where they break things? I'm looking to see if some combination of these just automatically breaks. There probably is some forced combination here that breaks that I'm not seeing. Let's see. Okay, so Garion says this can't be the high digit for this box. Because if this was a 5 and it was... Let's see. Can this be a 5 at all? I don't think this can be a 5 at all. So if this were a 5 and it went up, these would need to be 6, 7, 8. But that would make that a 9. That doesn't work. If this is a 5 and it went down, they'd need to be 4, 3, 2. And that would break this. So this 5 just can't ever be a 5. So that is something. So now this 1, 2, 3, this is now the lower end of this. So these are at least 2, 3, 5. So this digit needs to be at least 6. So this is a 6, 7, 8. For whatever that is worth. I suspect it's going to be worth something once I put it in combination with the right combination of things. Right. It can't be 7, because if it were 7, it would put the 7 in this box in column 7. So this is not a 7. could this really be a 6? If this were a 6, this would have to be 5, 3, 2, and 1. I don't see that. Okay. So now the cursed combination that I ignored earlier is impossible, Jim Baker points out. So I kept ignoring before the possibility that this could be the this could be the high digit and go 3, 2, 1 exactly, but it can't be anymore because this is a 1, 2, 3. So this is a 2 and a 6 and a 1. This is not a 2. These aren't 2. That's not a 6 or a 5. Oops, I pressed the wrong button. These aren't 1. Okay, these are not 1. Okay, so this is now a 6, 8, 9 triple. Why did I fill in a 2 there? I have no earthly idea why I filled a 2 in there. I could not even begin to tell you. That part is good, though. This is not a 6 or a 5. That part's good. These aren't 1. Yeah, I have absolutely no earthly idea what I was thinking when I filled that in. This can't be a 2, though. And now if this is a 2, it breaks. Because if this is a 2 now, this has to be 3, 4, 5. Looking at this 3, 4, 5, and that doesn't work. That's very cute geometry. I really like that. I guess the way to say it that doesn't make it cute is to say that there's a 2 in this box on this line, so this can't be a 2. But that way is ugly. Say it instead the other way. So that's a 1. Is the point. So got that. Okay, so this can't be a 6 anymore. Right. 1 in box 2, says Carl, is now down here. So this is now 1, 8, 9 as my triple. That one I know is not 9 at the very least. But 1 here joins those, which gets rid of the 1 here, which gives me a 2, 3 pair in the row, which tells me this isn't 2 or a 3, and that's not a 3. So those are a 4, 5 pair. So these between lines no longer matter. Sorry, between lines. This is getting awfully tight. Okay, so if this is a 6, it doesn't work anymore. If this is a 6, I would have to go 5, 3, 2, 1, and that doesn't work. So this now is an 8, which I think is going to do something to this skyscraper clue. This is a really impressively constructed puzzle. Not that that's any surprise from Tallcat, but I'm quite impressed. Yeah, I know where 8's going in this column now. 8 in this column now has to go here, is the point. Because if I don't put 8 there, this 3 skyscraper's broken. So that's an 8. This number has to be less than 8. These digits are at least 3. They're not 4, 5, 6, 7. That one seems to not be 7. That 8 has done a little bit of sorting for us. And in fact, that's actually very useful sorting, because remember the 8 and the 9 here had to go in order. So we have that. Let's see. If this were 3, these would be 5, 6, 7 exactly, which I'm sure would break something, but I don't know what. Okay, there's got to be an 8 in one of these two cells. I don't feel great about that as a useful fact, but it could be. Who knows? Let's see. Let's see. Garion says if this is 8, it breaks box 8. I think the easier way to see that is the same thing as Josh asks, where's 8 in row 9? And so by Sudoku, 8 in row 9 is one of these places, but it can't be in either of these places. So I think Garion saw that the other way around. But this now has to be an 8, because otherwise these skyscrapers would be capped at 2, and that would be sad for them. So these are an 8, 9 pair. So the 7 goes with the 8 for what it's worth, because the 7 can't go with a 9. It wouldn't make 3. And so one of these is 7 something 9, and one of them is not 7 something 8. Okay. So let's have a look here. So yeah, all I need is for this number to be less than 8, and then I'm happy with that skyscraper clue. So this skyscraper clue is automatically fixed. I cannot break this skyscraper clue even if I try. This skyscraper clue is automatically fixed. I can't break it even if I try. All the rest, actually, I think I can break if I try. So that's interesting. I'm told this has to be 2, 3, 4, or 5. So it's at most 6 by the skyscraper clue, but it can't be 6 or 7, and it can't be 1. So as Screaming Ice Cube says, this is 2, 3, 4, or 5, which does give us a quad in the box, which knocks out 2 and 5 from these. So these are from 1, 6, 8, 9. Ooh, Tristan has made an avatar for Tallcat that may feature the smile of the of this between line, the signature. Okay. Let's see. Tizy Boy says I can reduce 8 in box 5 to 2 places. So 8 in box 5 can only go in one of these 2 places, right? Actually, do I know this isn't a 9? Oh, well, I know. So here's what I know. I know I can't put an 8 on this line, because if I put an 8 on the line, I put a 9 here, and that breaks that cell. So even though I don't know if this is a 9 or not, I do, and I'm about to know, actually, but I do know I can't put an 8 on this line, because it would leave that cell with no value. So 8 in this box only goes in one of these 2 cells, which gives me a 9 here. Tells me there's no 9 here. So now, that was cool. I liked that a lot. Yes, welcome, Tizy Boy. I always enjoy when I get to see new screen names telling me Sudoku things. So now 8 in this box is now just outright placed here, which places the 8 in this box here. Which places the 8 in this box here. Let's see. Okay, do I have all the 8s? I have this little Joviewing of 8s left to fill. Okay. 9 in this box, I now know is in one of these 2 cells. Ah, I know where it is. 9 in this box, just by this 9, has been placed in one of these 2 cells, but it can't be here because of the 4 clue, so the 9 has to go there. And I know it can't go here because of the 4 clue, because this 1 building is never seen. It's blocked by that building. So this digit's at least 5, I guess I know. I can fill in this is 5, 6, 7, 8 at least. This digit now, is anything interesting about this digit now? I don't know. Oh, 9 in box 4 is placed. Chat calls. Thank you, Matt Pesto. And probably a few other people. Mario, I see, also saying it. So 9 in this box is up here for whatever that's worth. One of these two is 1 by sudoku. Oh yeah, where does 1 go in this box now by sudoku? 1 by sudoku now goes here, thank you to JLib. So that's now a 1, because I can't put 1 on a between line. And so if that's a 1, that's a 6 and a 1, and that's an 8, just by our pencil marks. So that's a 9 and an 8. Okay, and so now I know where the 7 goes. Namely, the 7 can't go here, because my skyscraper clue will be wrong. I will go 7, number less than 7, 9. So I have to put the 7 here in order to make that work. So we've got all of that. So let's see, I can clean up a little bit. That can't be a 6. Oh, and then I have only 1 9 left? No, not quite. Oh, but I do need a 9 in this column. Right. I need a 9 in this column. And if I look from this direction, it can't be there or there. And if I look just at pencil marks, it can't be there, there, or there. So Carl points out, yes, this is the only place for 9 in the column, which then makes that a 9 as well. Ooh, a snake sudoku. Oh, cool. I do like snake puzzles. Snake puzzles can be quite fun. Let's see. So this column actually doesn't have all that many digits left, but I also don't know anything about it. I have a little miniature thermo here. That digit is less than that digit. There's just an inequality sign, basically, to disambiguate all of this. Let's see. Where does 1 go in box 4? Ask Nicholas and Carl and Jaleb and Medi. 1 in box 4 goes here by sudoku is the answer. Welcome back, Isabella. So these are... I might as well write this in. I regret it. But so that's not a 1 anymore. So now that's a 1 by pencil mark. Let's see. So where does 1 go in this column? Right, 1 in column 2 now goes here. 1 in this box now goes here. And now that's all the 1s, and now that's all the 1s. Yep. Sad that ran out. Let's see. So... still love to break this being a 3, but maybe it's not broken. But this being a 3 makes that a 5, 6, 7 triple, which seems bad, but I can't actually prove it's bad. This digit has to be less than this digit, so this digit can't be more than 5. So this has got to be 2, 3, 4, 5, because this digit is less than that digit in order to make this skyscraper clue work. So 3, 2 seems okay. Let's see. I don't think I know that 7 is on this line for sure, because 7 could still sneak in there. Okay, let's see. 7 in box 8 is an interesting thing to look at. Interesting. Okay. So, can't go there. This would see too many things. It's not any of those. But I don't think I know which of these 3 it is, right? Because this could still be a 7, and then the skyscraper clue would be correct. see. Where is 2 in column 6? It's not there. If I put a 2 here, there is no digit I can put here that doesn't make this skyscraper at least too big. If I put a 2 there, then I just need this digit to be literally anything. So this being a 2 seems okay, and that being a 2 seems okay to me. Good point. So this digit in this box, where does it go? This digit in this box has to go here. It just has no choices. Let's see. Are there any other places we can play that game? Not quite there. We got our 1 and a 6 over there. So this digit's always a 2 or a 3. Actually, weirdly, we know the 2 in this box is going horizontally, so we know this isn't a 2. So now, we almost know something useful about the 2 in this box, because it doesn't go in any of those places, but it could sneak off there, I believe. Let's see, I can play the same game in row 3, column 8. Yes, where does this digit go in this quadruple? This digit in this quadruple, I see. This is not the between line game, this is the quad game. This digit needs to go here, so this isn't a 2 or a 3, because I need to put this digit in this box somewhere, and that's the only place it can go. Okay, so if this were a 5, then I would have to go... I guess that's not actually that bad to make happen. Let's see, row 3, column 7 in row 2. Yeah, where does row 3, column 7 go in row 2 is an excellent question, because it doesn't repeat on the between line or in the box. So it's got to be there. Very good. Okay, so that places a 9 here beautifully, which places a 9 here, which probably doesn't do anything, but I'm going to appreciate it anyway, because it's a digit. Oh, this is a triple. When did that happen? Because this is a triple, so I can fill in the middle digit. 1, 2, 3, 4, 5, 6. It's a 4, 5, 6. So this had better be the 5. And so that's the 4 and that's the 6. I really don't know when that happened. So these are 2, 3, 4, 5, 6, 7. These are 2, 3, and 7. So that gives me a 2, 3, 7 triple in this column, which means that's not the 2, so that's the 2. Which means that's the 3, so that's the 2, that's the 3. These aren't 3, so they are 4, 5, 6, which means where does the 2 go in the row, which means it goes there. It means this is a 4 or a 5. This isn't a 4 or a 5. This is the other 2, 3 for the box, in fact. This box as a triple has left 4, 5, and 6. That one's not the 4. It's a 5 or a 6. These are not 2, so that is the 2. Okay, so... yeah, that... so now I can write in these at least. 4, 5, 6 is what these are from. So, sorry, 7. That one can be 7. This one can't be 7. For whatever that is worth. Let's see. Row 6, column 1 is a naked single. Let's see. It's not 1, 2. Could be... no, it's not 3 either, because there's a 3, 7 pair. It's not 4. It looks like it could be 5, but it's not 6. It's not 7. It's not 8, and it's not 9. Yeah, this is a naked single 5. Nice spot to whoever first saw that. So that is a 4, 5 pair. This isn't a 5. So we've got that. Let's see. That skyscraper is done automatically. I can't break it anymore. I could try to break this skyscraper, so it's still giving me information. The 7 in this... Oh, no, I don't know that. Never mind, sorry. Let's see. Oh, yeah, this one's done. This one, I cannot break this one. So the skyscrapers I'm going to see in this column are going to be these 3 plus this one. So this needs to be bigger than that. So this needs to be 5, 6, 7. It can't be 8 because there's an 8 going in the box. So this is from 5, 6, 7, and it's bigger than that one. That is what some chat was pointing out. So let's see. We've got a lot of stuff that's sort of close to being a 4, 5, 6, 7 business, but not quite 4, 5, 6, 7 business. This cell is less than that cell. This cell is less than that cell. So let's see. Let's see. Row 4, column 9 is bigger than row 4, column 8. So I somehow know you're telling me that this isn't exactly 4, 5. How do I know this isn't exactly 4, 5? 2 in column 6. 2 in column 6 seems to be in 2 places that I see. So it's a skyscraper thing. Oh, well, I'm surprised that this skyscraper clue can possibly do anything. So the claim is that this can't be 4, 5, because then I would see 4, 5, 8, and 9, but I would definitely see the 6 or the 7 because I can only hide one of them. So actually, this digit needs to be bigger than this digit, which means this digit is not a 5. That is the thing chat saw. That's very cool. Josh and Matt Pesto, I think, were the ones I saw sort of spearheading, trying to get Zeta to understand that one. This is a triple. I probably should fill that in. 2, 3, 4, 5, 6, 7, 8, 9. Okay, this is not 2 or 4. It's not 5. These are from 1, 2, 3, 4, 5, 6, 7, 8, 9. They are not 8, apparently. That's not a 5. So, okay, so we've got a Jovi wing on 3s now, as Isabella immediately notices, impressively. So there's a 3 in one of these 2 cells. And so now that puts a 3 in one of these 2 cells, which I guess we already knew if we looked closely that one of these 2 had to be a 3. Let's see. There's a 2-3 pair in box 5. I still don't understand why this can't be a 2, and I don't... Oh, because it would make this skyscraper too big. Because if this is a 2, right. If this is a 2, this digit's bigger, and so I see 4 things. Okay. So yeah, if this is a 2, it just makes this bigger. So the 2 in this column, per Nicholas, really does go there. Which then is going to place the 3 like that. People keep saying box 5, but I don't see the box 5 thing that people are saying in box 5 that I'm supposed to see. So now this has to be, I guess, something else. Oh, they're just saying by Sudoku. Okay, got it. Okay. So the thing that people are saying that I was not getting is that there's a 2-3 pair, which I thought had something to do with something other than Sudoku, but it has nothing to do with anything other than Sudoku. Just because where can 2 go in this box? Because of this 2 sort of hiding here, this 2 pushes that 2, pushes 2 here, which makes this a 2-3 pair. That's That's what chat is saying, and I agree with that assessment. This is a 2-3 pair. So these are from 4, 5, 6, I believe. Yes, these are from 4, 5, 6, and I know something about the order, actually. Namely, I know this one can't be the 4, because if this were the 4, I would only see 2 skyscrapers, so actually that's the 6. So no 6 over there. And now this skyscraper is automatic, so I can X this skyscraper clue. It is done. I can't break this skyscraper clue either, because every digit I can fill in here is between 3 and 8, which is all that needs to be true. So this one's done. Let's see. I need to hide a 6 or 7 in this row. Is that the point? That's probably the point. If I don't hide a 6, 7 in this row, then I'm going to see this cell. I'm going to see the 6 or the 7, and then I'm going to see the 8 and the 9, and that's too many cells. So if I don't hide a 6, 7 behind this 8, I'm going to see it. And so then I'll see 2. Oh, wait, no, that's not true. Sorry, never mind. I can't count. Never mind. Because I still need to see, I do need to see 4 buildings. But I can hide the 6 behind the 7, as Garion says, which is absolutely correct. I somehow thought I couldn't see either of them, which I don't know how in my brain I thought that was going to work. Bye, Ambrose. Let's see. This cell is 4, 5, 6, or 7, but it's not 6, so it's 4, 5, or 7. One of these 2 cells is 2. I don't know which one. Oh, I do know which one. It's there. That's the 2. So that's not a 2. So we've got a 3, 4, 7 triple there. So now the 2 is placed over here in this box down here. So this is 4, 5, or 7, but it's not a 4. So this is only 5 or 7. Let's see. I still have to be a little bit... No, I don't have to be careful with this. This is going to see that one, that one. Oh, I still do need to be careful because I need to make sure this digit is less than that digit. Okay. So this is 4, 5, 6, or 7, but it's not 5 or 6. So it's 4 or 7. So it's going to be one of these by-value cells is going to get broken if I try and do this. So some combination here is not going to work. But I don't yet see which one. But I can't put any of these by-values in here. I'm afraid I'm at some point going to have to actually look at this row, but I don't want to because it looks horrible. So yeah, so we've got... Okay. So is the thing that goes wrong if this is 7? If this is 7, then this is 4. And these are a 5, 6 pair, but they just have to go in the right order. That's okay. Let's see, if this is a 5... right, okay. So the point is, if this is a 5, then that's a 7, so that's a 4, and this number can't be less than 5. That's ugly. But it's true. So, and it's exactly what I was saying is going to happen. It's this string of by-values here in this column. So if this is a 5, it makes it impossible to make this a 4, which is what it would have to be. So I was looking for ruling out making this too big. This is the next thing I was going to look for, was making this too small. Yeah, that can't be a 5. It's too restricted. So that is a 6 or a 7. So now this is automatically bigger than this, no matter what I do. And so now this skyscraper is done. And now I really have to look at this row. I don't think I can possibly get away with not looking at this row anymore. So Carl points out this can't be 6 because then this would go 6, 7, and I would now see 5 skyscrapers at least. So this can't be 6. I agree with that. So one of these two is 6. It's not super exciting. 5 in this box is actually in this column, so that's going to give me a few sudoku things, like that those aren't 5. This being 5, beautiful, beautiful. This can't actually be 5, J40 points out, because if this is 5, it makes that 4, and now I see the 4, the 5, the 6, 7, the 8, and the 9, so that doesn't work. That's gorgeous. Okay, I really like that. So this is 5. Now there's a 2, 3 pair in this row, so that's a 6. So that's not a 6. So now there's a 4, 7 pair in this column, so that's a 6. That's not a 6. Now, oh, that's right, this column's already done. Okay. So this cell is always bigger than that cell and that cell. Yes, there's this 4, 7 pair in this box, which just makes that a 6. I don't have to think about it. So I want to make sure I see these 4 cells and nothing else. But I think that's going to automatically happen now. I don't think I can break it anymore. I think it is true to say there is no combination that breaks this. Also, it is true to say that this is where the 5 goes in the row. And now there's definitely no combination that will break it. So that's not a 5. This is a 3, 4 pair, which makes that the 7 and the 5, and the 7, and the 4, and the 7 and the 5 and the 4, and the 5 and the 4, and the 3 and the 4, and the 3 and the 2, and the 4 and the 5, and the 4 and the 5. 3, 7, 3, 7. Oops. 2, 3, and the betting tree is a 4. Loved that one. That is one of my favorite Tallcat puzzles. That was great. Quite enjoyable. I particularly enjoy that for an over an hour solve, I had colored where the 9s could go in like the first minute of the solve before I started looking at something else, and then just never got rid of it. Yes, Tallcat has changed to the Cheshire cat now, but with the Cat in the hat, which is very appropriate. I'm hoping that for the 100th stream, Tallcat will wear his Tallcat hat, but we will see. Alrighty, I am going to take a quick break, and then we're going to do a couple 6x6 puzzles to wrap up, because we do have a date with the cave later, so I can't go doing too many more puzzles, but I'll do a bit more. So I will be back shortly. Alrighty, welcome back. So we have an Isabella 6x6. This one involves doublers, I believe. No, it doesn't involve doublers? Did I just imagine that? Apparently it does not involve doublers. Oh no, there are doublers, right. There are doublers, right. So there's a doubler in every row, column, and box. And each digit is doubled once, so sort of quote-unquote standard doubler rules. Although what's funny to me now with the standard doubler rules thing is now people are looking at vignettes, because Simon and Mark did it, and vignettes does not have that rule. And so it is throwing some folks off when they go back to look at vignettes. Alrighty. So what are we going to do here? So these two digits add to 5. These two digits add to 10. Let's see. So I know the parity of the double digit in each of these rows. So that's the point. That's the point. So in each row, I need to make the sum of these rows even, because there's an equal sum across these, whereas the sum of 21 is odd, and so that means I need to double an odd number, and so the doublers in these rows are all odd numbers, and so the doublers in these rows are all even numbers. Is cute. So the doublers, so just to repeat that, the doublers in these lines are all odd. And so if I'm doubling an odd digit, unfortunately I can do that with a V. I can do that with a white dot, and I can do it with a black dot if I double exactly a 1. Let's see. A doubler can be on either side of a black dot. This is a 1 and that's a 4 and this is doubled. I only know that because that's part of the break into vignettes, but you can definitely have a doubler on a black dot. But the only way to do it is with a 1 and a 4. Let's see. But there's a doubler, Jaleb. So I guess the question is, what is my sum going to be? So I know what these sums are going to be. That's the point. So what are the sums going to be? So when I add the doubler, I'm adding either 1, 3, or 5. So when I add 1, I go to 22 and the total is 11. When I add 3, the total is 12. And when I add 5, the total is 13. So the total of these is either 11, 12, or 13. Is there one of these that... okay, so if the total is always 11, 12, or 13, that means that this is always 1, 2, or 3. And if the total is always 11, 12, or 13, that means this digit's a 6. Because that's the only thing I can get to, right? If I need to get to at least 11 and these add to 5, this can only be a 6. Oh, but it could be a doubled 3. So this is a 3 or a 6. This counts for 6, but it might be a doubled 3 in order to get there. Okay. So this digit counts as 6 and is either a 3 or a doubled thingy. Oh, but right, I could get there by... Sorry, Jaleb is right. I don't even know that, because I could actually, instead of getting to 11 with a 6, I could actually get to 12... No, I can't get to 12, but I could get to 13 with an 8. So this can be a 3, 6, or a doubled 4. A doubled 5 gets me to 15, which isn't an option. Welcome, Eve Clue. So yeah, so that's possible. Okay. So these digits are a multiple of 3. Right. I know that I already said the that's right. That's why I was looking. Okay, right. The things that are doubled are odd. So yeah, double 4 does not work. So yeah, it is. This does count for 6. So this is the 11 line, actually. That's what I should say. This is the 11 line because every option involves this cell counting for 6. So this is not the 11 line. So this is a 2 or a 3. So I know where the 5 goes in this row. Because even with doublers, I can't put 5 anywhere but here. Woo-doop! Dup-a-dup! So this is a 5. So I need these two. These two are always going to sum to a multiple of 3, and so that's the point. 5 plus multiple of 3, what do I have? 12 is not 5 plus a multiple of 3. 13 is 5 plus a multiple of 3. And so the only way this works... could the 5 be doubled, is the question. If the 5 is doubled, then I would need to have this count for 10, and I would need the black dot to count for 3, which I could just do. That's annoying. Okay. But even if it's doubled... Okay, so... Even if it's doubled, I still can't be going to 12, because double 5 is still not divisible by 3. So even ignoring all the business with doublers, this is always a 3. This has to be the line where the sum is 13, because these are always a multiple of 3, and this isn't, whether it's doubled or not. And so this needs to sum to 13, which means this cell needs to count for 3, which means it is 3, and we have our first cell in the grid that's not doubled. Okay, and Chad is pointing out that actually I need to double the 5, because otherwise I'm getting the wrong modulus. Because if I don't double the 5, then what's going to happen is I'm going to get a number that is 2 more than a multiple of 3, and that's not going to be good. So I have to double the 5, coolly enough. This is a very sweet implementation of this idea. So now, in order to get to 13, which I know is the target, I need to make these a 1, 2, and so these are a 4, 6. And so the double digit in this box is a 2. I don't know that I care, but the double digit in this box is a 2. I'm just... Even though it's ridiculous, I'm going to put a corner marked 2 to try and remind myself unsuccessfully that it's the 2 that's doubled here. So we knew that this row had to sum to 11. And so this row sums to 11, this row sums to 13, so therefore this row needs to sum to 12, which means that this cell has to be a multiple of 3, because 12 is a multiple of 3, and these two add to a multiple of 3, so I need to keep that. So this is going to be 3, 6, or 9, and it's probably not 9 in this puzzle, so this is a 3 or a 6. In order to keep myself working. Right, and so... so what would happen if it was a 3? Because I need these to sum to 9, if this was a 3, I would need these to... I would need these to sum to 9, unless the 3 was doubled, in which case I would need them to sum to... Sorry, if the 3 is doubled, I would need them to sum to 6, so there'd be 2 and 4. But a doubled 3 works, Screaming Ice Cube. So doubled 3 and 2, 4 works. And as being pointed out, actually, I I did this way more complicatedly than I needed to. As soon as I knew the sum was 13, I knew the double digit was a 5. And so here I know the double digit is a 3. Here I know the double digit's a 1. So I should have just done this right away, because in order to make the sum work, the double digit has to be a 1. So this digit can't be a doubled 3. It just is a 6. So yeah, there's a doubled 1 living over here. And there's a doubled 3 living in here. So this cell always counts for 6, is the point. Because it's either a doubled 3 or it's a 6, which means this black dot always adds to 6. And the only way to do that is with 2 and 4. So that's very interesting, because I definitely need an even digit for this dot. But it could be the doubled 3 that I get for this dot to make that work. Eve, what we are doing is we are doing various sudoku things. So we are doing this puzzle where the rule is that the sum of the digits on the blue lines need to be equal in each box. And so chat points out, by Sudoku, where does 5 go in row 4? I need to put 1. I can't put it in any of these cells because there's already a 5 there. So there's definitely a 5 on this dot. And that 5 either needs to go with a 3 or a 6. So that gives me a 3, 5, 6 triple in the row, ridiculously. And so that tells me what this digit is. It's a 1. So we've got that. So now we know we are doubling the 3. So the double 3 goes in one of those places. I don't yet know how I'm going to disentangle that. I don't think I can disentangle the V yet. I know I'm doubling the 2 here. How do I know 3 is on the V in row 1? Right. The 1 and okay, so what does my V look like? I need to find two numbers that add to 5. And Eric's point is that the 1 here, the white dot is not wrong, because the 3 could be a double 6. The 3 could be doubled, which would make it a 6, and 6 and 5 are consecutive, Amy. Because we have doublers floating around. But anyway, sorry, I will continue explaining Eric's point. I understood it, but then I got distracted. So there's a doubled 1 in this row. That means this V can't be a 1, 4, because that would sum to 6. So what are the options? I either double the 1 and put it with a 3, or I just put a 2 with a 3. So these digits are from 1, 2, 3, and they always involve a 3. And what that means is that over here, we definitely have things like 5 and 4 and all of that kind of nonsense. Now, what does that buy me? Does that buy me anything? So I don't know is the answer. Yeah, one of these cells is the fake 6. It's funny that there's a fake 6 and a real 6, and the thing we really don't know is just which is which. I do know these aren't doubled, for whatever that's worth. It's probably worth something. I should definitely indicate it for what it's worth. Let's see. Let's see. Double 4. So, So J is looking for the doubled 4, because I need to double a 4. I can't double a 4 in this box or this box. And I can't double a 4 in this row. How do I know I'm not doubling a 4 in one of these? 4 is on the line in box 1. Yeah, 4 is... Oh, right. 4 is on the line in box 1, right. 4 and 5 I know are actually both up here. And so they're not doubled. So that's true. So the doubled 4 is in one of these cells. That is true. Okay, I'm on the page there now. So then the question, I guess, is where am I doubling 6? So I'm not doubling 6 here. So I have to double 6 in one of these places only. Right. Okay, that's gorgeous. Okay, Carl has framed this in a way that finally my brain has understood. If this is a 6, I've used all the even numbers in this box, but I need to double an even number in this box because all the odd numbers are on the line. So this has to be the doubler. It's the only place to put the doubler, because if I don't, I use all the evens. That's gorgeous. Okay. So this is a 5, which is not doubled, and a 6, which is not doubled. Okay. Got it. Okay, so now that's a 6. These are a 3 and a 4. These are 1, 5, and 6. These are 2, 3, and 4. These are 1, 2, and 5. Let's see. Okay. 5 in box 2. Ah, yes, 5 is placed here. So it's not doubled. I can do a bit of graying. That's true, because I have this doubler. Let's see. So the double digit here is a 2, remember. So this is not a 2. This is only a 1 or a 5. One of these two is the 2. Ah, so one of those two is the 2. So that gives me a Jovi wing on 2s. So that tells me there's a 2 up here somewhere, for whatever that's worth. Right. So I need to double so this is 2 to 10th point. I need to double an even number in this box. What even number am I doubling in this box? Well, 2 I've already doubled down here, and 6 is already gone. So there needs to be a 4 doubled in this box. It's the only option. So this digit is not a 4, which gives me a 2, 3 pair in the column, which means that's a 4. So these are 2, 3, 4 is the options for these cells. So this cell has to be a 1, 2, or a 3. So now I need to double 6 still. And so where am I doubling 6? Well, I can't double 6 there. So I have to double 6 in this box. So if I'm doubling 6 in this box, that means these are gray. Which means that my doubler is actually in this row. Oh, I already knew this 6 wasn't doubled from a long time ago. So I actually do double this. And so that's a doubled 1 and a 3. So now I can do some more graying. So that is gray. That's gray. That's purple. So let's fill in some more sudoku. So that's a 2 and a 2. I knew what this was going to be. This is going to be a doubled 4 and a 3 and a 4 and a 3 and a 1 and a 2. So let's see. So again, I know there's a 6 over here somewhere. Let me just write in the candidates as to what's actually going on here. I know this is the 2 from my previously observed Joe viewing on 2s plus that. So this is a pair of 4 and 5. This is a triple of 1, 3, and 6. Except I know this isn't the 6 or the 3, so this just is the 1, which makes this the 6, which has to be doubled. Makes that gray, makes that gray, makes that a doubler. So that is a 3, and a 5, and a 6. This I know is a 2, so that's a 1. That's a 4 and a 2, and a 5 and a 1, and a 4 and a 5, and a 6 and a 4. Wow, that was great. That was a wonderful little romp through that. There's an amazing amount sort of packed into it. I loved the sort of break-in of thinking about the odds and evens. I found that to be quite enjoyable as a sort of way to set up everything in this puzzle. Alrighty, I'm going to grab whatever the next 6x6 is, and I will be back in 20 seconds. Next up, Andrewsarchus. So this is a mean mini. So note that changes the rules. So instead of placing the digits 1 through 6 in every row column box, we now need to place a subset of 1 through 9 in every row column box. But the subset has to be the same for every row column box. So I basically have to, as part of the puzzle, identify what the 6 digits that this puzzle uses are. Okay. Additionally, in this puzzle, it's 0 through 9. Sorry, good point. 0 through 9. And there are doublers as before, so that works exactly the same. And then there are region sum lines. And so all lines are region sum lines. Different colors are used to disambiguate intersecting lines. So again, the sum of these 4 digits goes here. The sum of these 3 digits, the sum of these 2 digits goes here, and so on. So I have a sort of funny thing going on with this, because of the fact that there's a 0 involved, I might put a 0 on here, or I might double this cell, or who knows, I could do both. But if I don't put a 0 here or double this cell, then it's broken. Now, normally, a 2-cell region sum line would be super nice, because normally a 2-cell region sum line would tell you that these two are the same digit. But they definitely don't tell me that here, because if these two were, one of them could be a doubler and the other could be organic. I suppose what I know is they can't both be doublers, which doesn't seem like the biggest deduction ever. I mean, I know this digit's at least 3, but that seems absurd to attempt to pencil mark in this puzzle. Let's see. I would really like to see some clever way of realizing there can't be a 0 in this grid, but I A, think that because it's Andrew, there probably is, and B, don't see a way to think about like whether there could be a 0 or not. Let's see. Okay, so you know that these sum to an even. So, I mean, this does give me perhaps a bound on how many low digits I need. Yeah, this is slightly shorthanded because these are the standard mean mini rules, except for the fact that you can use 0. But in mean minis, you have to only use the same set of digits in every row, column, and box. But I agree, if this is the first time you've seen a mean mini, these rules are a bit abbreviated. Let's see. I agree with Gary, and I need at least 1 digit smaller than 5. Which doesn't feel like a fantastic start, but I was about to say so. I might even be able to convince myself I need at least 1 digit smaller than 4. Let's see. Okay, but what on earth am I supposed to do here with any of these lines? Let's see. These red lines are all sort of dancing around here. I mean, 0 is less than 5. Oh, that's it. Okay. So let's write down the cells that this cell is a sum of. Okay, so this is J's observation. So these two cells sum to this cell. This is where we're putting all of our attention at the moment. But that cell, actually, it's the sum of these two cells. But that cell actually has the same sum as that cell, which then in turn actually has the same sum as those two cells. But this cell actually has the same sum as these two cells. And this cell has the same sum as this cell. And so I think the point here is that this circle is the sum of these 5 cells. Which has to sum to at least 4, I believe. I think the answer is this digit has to sum to at least 4, so it could be a doubled 2 as well. So that is not fantastic news, if I am honest. Let's see. So I guess the question is, can I somehow enhance this by sort of moving these around in a different way? Maybe, possibly. Let's see. I can collapse the greens further. So, okay. So this I could move to double these two. And so now this I can collapse to actually make this triple these. And then I can move this one here twice. So we'll do that. So the sum is actually, I believe if I did that correctly, it's 5 times this cell plus 3 times this cell. Yeah, so it is 5 times something plus 3 times something. So what can I do with that? The digit that's used 5 times... Yeah, 5 times 0 is still 0 is a problem. Is it possible that this digit being 0 would not work for some reason? Yeah, we've actually made our approximation significantly worse if this can be 0, because before it could be at least... It had to be at least 4. But this cell if this cell is 0, it says these two are the same, and says these two are the same. But these two are also the same. Okay. So yes, so here's the thing to look at. If this is 0, this is also 0 because of that line. But now these two cells have to be the same, but they also have to be the same as that. Wait, I'm not quite getting far enough in my chain yet to break this. In my head, I thought I believed that I had an easy way. So these two are the same, so one of them is definitely a doubler. One of these two is definitely a doubler. But I don't think that works. Once we got past the whole power outage part, then it has all been nice. Oh, is that the point? Yeah, so these two are the same. So one of them is a doubler. Right. This cell, one of these two. Oh, I mean, we're fine. There's no weather or anything here. Our power just went out. Yeah, we to be clear, did not have a power outage because we had some sort of event. Yeah, so one of these two would be a doubler. One of these two would be a doubler. This is disgusting. Yes, Daniel is the storm. But why can't this just be the one that's the doubler? Because of the red line. Because it's equal to both of these. Oh, Lord. Okay. So, so if this is the doubler... Oh, Lord. Let's see. I'm just going to say this can't be 0. I don't care. We're just going to say this can't be 0. People in chat see it, and I don't feel like thinking about it. And it's going to be... It's a chain that is 25 steps longer than I'm comfortable with. So we're just going to say this is not a 0 and just go on with it. Because we're already in a chain in order to even get here. So we're just going to say this isn't a 0. So it's at least a 1 is the intended deduction. So this is at least a 1. Does that also tell me this isn't a 0? I don't think so, unfortunately. Let's see. I fear that that I'm still going to need to do something gross here. Okay, so this is 1, 2, or 3, because if it's 4, remember it's getting multiplied by 5. That's way, way, way too much to show up down here, because this is... So the thing we know, Meme Rister, and this part is very cool, is that this cell is equal to 5 times this cell plus 3 times this cell. By sort of like pushing along these equal sum lines. That part I thought was very cool. So it's at least 5. But I again am confused as to what I'm supposed to do with this. So 5 times this plus 3 times this. What am I going to do with that? So if this cell is not a 2, it repeats there. Let's see. Yeah, I agree 5 times 3 plus 3 times 1 equals 18 is very plausible to be here. But if this is a 1, this could be over here. Yeah. Let's see. So Andrew is saying I should look at this as a series. So, and just think about something about like these two cells. So, okay, here we go. Here's a deduction that actually matters. This cannot be a double 9. Because if this is a double 9, I need to make these two sum to the same thing. And I can't, because I've used the doubler. And so if this is a double 9, I can't make these sum to more than 15. So my total can't be more than 15, because if this is a doubler, I can't use a doubler here at all. And so, in fact, I can at least trim off a little bit off the top. So I can't even make this a 3, is the point, because I think if this is a 3, then the minimum my sum is 16. No, I could do 16. 16 is fine, because I can do 8 doubled and then 7, 9. So I think 16 just works, annoyingly. But I think the key is that one of the things in here has to be a doubler. Let's see, Jay says this has to be a doubler. Okay, let's see. I'm trying to trace through Jay's thing. So if row 2, column 5 is a 0, and row 2, column 4 is a 1, row 2, column 4 is a doubler. Right, okay. So the sum has to be at least 10. Right, okay, got it, okay. So, the question to ask is it possible that the value of this cell is 1? And the answer is it's not possible that the value of this cell is 1. This is J40's point. So why is it not possible that the value of this cell is 1? It's because if the value of this cell is 1... wait, no, I don't... I no longer think this works, because this was... The only question was, could this be 1 and that be 0? But this can't be 1 and that be 0 without a doubler. But I don't think that tells me that I can't do, say, a 1 with a 2 here and make the total 7. So we do know this can't be a 3, though, because it's 5 times this plus 3 times this. And I know the total if the total is double digit, it has to be even, because it would have to come from a doubler. And so I think we've shown that 5 times 3 plus 3 times 1 is already too big. Yeah, we've definitely shown that's already too big because of these two cells. So this is not a 3. So if... Oh, right. A 1 with a 2 is not making the total 7. No, it is making the total 7 for purposes of this cell, which is what we're talking about. Okay, if this is a 1 with a 2, for purposes of this cell, what would it do? A 1 with a 2 would make this... Okay, so this is the point. Okay, I see the sort of like... I see the structure of J's proof by cases now. So if this is a 1, and it actually counts as a 1, I still can't put a 0 here. We proved that. If this is a 2, this is already a double-digit number. But if this is a 1 and this isn't a 0, then my total is still at least 5 plus 6 is 11. So I think we've proven the total's always a double digit. So I think the point is this is always a doubler. I guess I probably should not mark it in purple, given that I've used this to sort of indicate the times 5. So that's the doubler, which does mean the sum is even. Because now the sum is really... That was not good coloring. These aren't doubled. That's not doubled either, but I'm just sort of keeping track of my counting. So the sum is even. So I have 5 times something plus 3 times something is going to be even. So if this were 5 times 1, this would still need to be 3 times, and it would need to be 3 times an odd number. I want to say same parity, but I don't know that this cell isn't a doubler. So if this is a 2, this could be a doubler, and they could not be the same parity, at least as far as I can tell. But otherwise, they're going to be the same parity. So if this is a 1, this needs to be a 3, at least. And so let's see, does 1 and 3 already break the bank? 1 and 3 would be 5 times 1 plus 3 times 3 is 14. That doesn't seem broken to me. Yes, at least it's not 0. I grant neither of these cells is 0. Because I'm slightly worried that this could be 2 and this could be 0. And that might be okay. Would make this a 5. Is it obvious that this being 2 and this being 0 doesn't work? I don't think it's obvious to me that that doesn't work. So if this were 2... Oh, no. If this was 2 and 0, this would be a doubled 5. Yes, that doesn't work. Okay, thank God. Okay. This being 0 doesn't work either way. So the parity is wrong if this is a 1. And if this is a 2 and a 0, it makes the total 10, which would require a doubler here, which would also require a doubler here, and that does not work. So this can't be 0. So this is also at least 1. And so, am I wrong? I think Jay thinks I'm wrong. Wait, no, right. I'm doing the completely wrong thing, right? Because this arrow is not multiplying this by 5 and this by 2. This is the one that is. So that does not work at all. Sorry. So the thing I said does not actually work. Let's see something. So yeah, I think this can be 0 as long as this is even. I do know this isn't doubled. I need to remind myself that I know this cell isn't doubled. So it either really is a real 1 or a real 2. And if it's a real 1, then it goes with an odd number. And 5 has to be way too big, right? If this is a 1, then 5 times 1 plus 3 times 5 is too big, right? So 1 only works with a 3. If this is a 2, then 2 times 5 is 10, plus 3 times, and then it's got to be an even number here, but it could be even because it's been doubled, unfortunately. But the biggest value I could get is 4. No, 4 is already too big. 10 plus 3 times 4 is too big. 10 plus 3 times 2 would be 16. But this is already hypothesized to be a 2 in this universe. So, right. So if this is a 2, this can be a doubled 1 or a 0, I think. I think that's the options. So is 16 too large is the question. So if this is 16, this needs to be 7, 9 exactly. That would be an 8. So I think we might have to look ahead a bit to see that 16 doesn't work. So it would have to look like that in order for this to be 16. But this could still be something doubled. So I unfortunately, I think 16 is exactly possible with column 4. Let's see. I don't know what I did to Andrew. I'm sorry, Andrew. Whatever I did to deserve this, I apologize. Jay says everything in the sequence has to be even, but I feel like I'm miles away from understanding whatever people are talking about with this sequence. Well, let's see. So I'm trying to understand this. So if these are both even, this is even, and that's even, and so therefore that's even, and that's even, so that's even, so that's even. Right. Okay. I get this now. Okay. So if these are both even, then in terms of value, then so are these. They're both even in terms of value. And so then so are both of these in terms of value, and so are both of these in terms of value. And so then these would need to be both even, and so they can't be 7, 9. So I can't do 16, and so I can never do a 3 here. So this is a 0 or a 1. Okay. So, well, that tells me there's definitely a 1 in the puzzle. 1, 3 is okay. What did we rule out? I thought we ruled something out there. Let's see. Oh, this can't be a 1 anymore is the thing? Right, if this is a 1... Sorry, if this is a 1, this would be a 2, so this would be 2 times 5 plus 3 times 1. But 3 times 1... Oh, it ruled out a doubled 1, but not a singled 1. I mean, I'm probably not going to finish this puzzle, because I have to leave to go to a cave soon. But I don't really want to have a third puzzle I've not finished on stream, but we may be in that situation. We may be in a third puzzle that Zeta doesn't ever do situation. Singled 1 is impossible. Right, a singled 1, a not doubled 1 here would of necessity go with an odd number here, but that doesn't work. So at least I agree with Jay Dyer. This is never a 1. Let's see. It's funny that that's going to mean that 2 of the puzzles we have not finished on the stream are 6x6s. Because one of the others was a 6x6 by Glipperl. There was also a like full grid coloring Taurus puzzle that I did not finish. I do not remember the setter of. Okay, let's see. So what are we doing now? Should it be obvious to me which of these things is happening? So if this is a 0 and a 2, that makes this a 5. Otherwise, this is a 1 and a 3, which makes this a 5 plus 9, which is a 7. So is this always a 5 or a 7? Is that part of the moral here? So this is always a 5 or a 7. Okay, so Jay agrees. This is always a 5 or a 7. Which means it's always doubled in particular. No, that's not how it works. Still not how it works. This is not 5 times this plus this. This is just the sum of these. So no. So this sum is actually, it's either 1 plus 3, in which case this would be a 4, either which way. So either as a doubled 2 or a 4. Or it is a 2 plus 0, in which case this would be a doubled 1. So I think this is a 1, 2, or a 4. Well, I do know that this cell is 1 or 2, because it's got to be the same sum as that. So this is so I can fill in 1 or 2 in this cell, at the very least. And so, so in the universe where this goes 2, 0, this needs to be a doubled 1, and that's a 2. I think I'm believing this is never a doubler, but I could be wrong. Let's see. But it is true that this is either 5 or 7, because the sum of this cell is either 10 or 14. Okay. So would I really just need to think about all of these cases? So 5... So, sorry. 1 plus 3 would make this 4. So that would make this cell either 2 or 4. And 2 plus 0 would make this a double 1. So this is always a 1, 2, or a 4. So the universe where this is a 0, these two are the same. And this becomes a 4 because I have to. in the universe where this is a 1 and a 3, this is let's see, I'm encouraged to look at the row 6, column 3 cell. Okay, so Andrew says, look at this and see if it's possible it's not that digit. So if it's not that digit, then it goes on the line because it'll go in one of those two places. And then if it goes on this line, then it's going to go with... but then Andrew says it has to be doubled, even if 0 is on the line too. Because it's on the line, right. So this would be a doubler if it's not equal to that. Is there a reason this can't be a doubler that we are aware of? Because obviously if it's the same as this, it can't be a doubler. But it has to not be the same. I'm hoping it has to not be, or I'm hoping it does have to be the same as this. Or is there a reason it can't be the same as row 5, column 4? I don't know. If it's not doubled, it must be a 7. If it's this, yes, if it's the same, it has to be a 7, which is what I would like to prove. Let's see. So, okay, so Andrew says I'm supposed to look at two cases. So one case is that this is the same as this, in which case it has to be a 7 because the sum of this has to be bigger than 5. If this is the same as this, then it's a 7, and so that means we're in the 1-3 case. Otherwise, this is a doubler, and that means there's no doublers here, which means we're in the 1-3 case, because otherwise this would be a 0. Okay, so we're in the 1-3 case. Woo! So this is a 1 and a 3 is the point, regardless of what's happening here. So this is not a 1. So this is either a doubler to say that it's a 2 doubling to 4, but this is definitely a 1. It has to be a 1. So, and these need to sum to this digit. There was some parity business that I was missing where all of these were supposed to be the same parity or something, maybe? I do know this isn't doubled now. The sum is always 5. That's a good point. So I know that this is a 4. So these sum to 5. And so this is a 2 or a 4. But it always counts as a 4. And so this sums to 9, regardless. And so if that's a 9, remember the whole sum in the 1-3 case was 10. Right? No, that's not true. No. Where in the 1-3 case, it was, the sum was, why can I not keep this straight in my head, was 14. So this is a 7, is the point. This is a 5. 5 is not doubled. That's true. So we've got all of this. Do we know all of our digits now? So we know, well, I know this has to be a 3 because this column needs a 3. So therefore this isn't a 7 because I can't have a 3 on a line that sums to 7, even with a 0. So this is not the 7. This is something else. And And so it has to be doubled, whatever it is, I think was what we proved. So that thing is doubled. Good point from Jay. I only get one more digit, so these have to both be 4 and both not be doubled, because if one of them is doubled, they'd both have to be doubled, but they can't both be doubled because I'd be doubling the same digit. So that's great, and it's a 4, and it goes there. So these cells are, let's see, we've got to do this. 1, 4, 5 means these are a 9, 3, and 5. No, not 5. 9, 3, and 7. But we already know this can't be 7 and it can't be 3. So this is double 9, actually. So these need to sum to 18. So is that even possible, or did I screw something up? I probably screwed something up. Oh, I don't think I knew that this was doubled. I don't think that's right. I think I didn't know that this was doubled. Because I bet it sums to actual 9, not doubled 9. But it is still true that these have to both be 4. This is a 4. We're really racing against the clock here. These are still 1, 4, 5. These are still 9, 7, 3. Right, it goes on its own line. Okay. And it couldn't be 7 because it needed to be doubled. Okay, so so that is a 3. That is a 7. I do know this is doubled. So one of these is a 9. I need the other digits to add to 9. So I need a 3. And out of these digits, the only way to add to 9 with a 3 I need to add to 6 is with a 1 and a 5. So these are 1, 5, 9. That's not a 9. So therefore, this is the other one that it did not appear there. This is the 4. So we therefore, probably the rest of this is almost Sudoku at this point, but I'm probably not going to be able to finish it, but let's say I will try. So these are 1, 3, we've got the 4 and the 5 and the 7 and 9. Okay, well this isn't a 1, because I don't have any zeros. So if this is the 3, I can't actually add to 3, this has to be a 9. So this is not a 9. This therefore is a 1, because I can't put a 1 here, I'd need an 8 here. So this is a 1. So that's a 5. These aren't 5. These two digits are 4 and 5, which do add to 9. That's good. So that's a 5 and a 4. This isn't doubled for sure. This digit is known. It's a 7. It's not, neither of these are doubled, in fact. So we need a 3 here just by Sudoku. These aren't doubled. Let's see. Okay, this is known to be a something. 1, 3, 4, 5. This is known to be a 7. So it's not doubled. And therefore the double digit in this column is a 4? No, that doesn't work. No, sorry. The 4 can't be doubled. Therefore the double digit in the column is a 3. So these are all not doubled. So this is double. Oh, I don't know anything about whether these are doubled. I'm just going to get rid of the coloring because I don't need it anymore. Well, I do know this isn't doubled. Oh, actually, no, I do know both of these aren't doubled because of the way the whole thing worked. So I need to put here a 9 and something else. A 9 and a 5, it looks like. I don't know the order. These 3 digits are 7, 5, and 9. Sorry, 7, 5, and 9, not 8. 7, 5, and 9, not 7, not 5. This is doubled, though, and because it's doubled, it's not a 9, it's a 5. So these are gray. This is not 5. This is a 9, and this is a 5. I must be doubling a 1 over here for what it's worth. Let's see. So I guess I better write these in. So these are 1, 3, and 7. That one's not a 3. These are 1, 4, and 3. It's not a 4. That's not a 3. Okay, I need to be doubling a 1 over here, so I'm not doubling a 1 over here, and I'm not doubling a 7 either. So I need to be doubling a 4 in this box. And so in fact, this is a placed 4, but I also have to double it. So this is not a doubler. That's not a doubler. This is a doubler. So the double digit over here has to be a 1 because I've already doubled a 3. So that's a 1, a 7, a 3, a 9, a 1, a 9, and a 7. And I think we made it just in the nick of time. Tristan told me I had till 2:15, so I have 1 minute left. So thank you very much to everyone who came to the stream today, even though we had more technical issues than usual. Thank you to the people who support the channel on Patreon or YouTube. If you're enjoying the channel, please consider supporting. We greatly appreciate it. Thank you especially to the people who donate at the top level. That is David, Michael, Nordy, Franco, and Woofer. Thank you so much. Thank you, all of you. I look forward to seeing all of you wonderful people soon. But I've got to run now, so I'm just going to shut down the stream and head off. So please like the stream, comment, subscribe, all the good YouTuber stuff, and I'll see you all very soon. Bye for now.